Hey all, my name is Brian Donahue. I'm a director of engineering at DoorDash, and good afternoon. I want to welcome you to the Android Technical Showcase event for DoorDash. We have a really great set of presentations for you, and I'm excited to get into it. So let's have a look at the agenda. So here's kind of an overview for the event today. We're going to spend a few minutes at the beginning doing some welcome and introductions. I'm also going to give a brief overview of Android at DoorDash. Then we're going to have a 15-minute talk about what we learned from our Android rewrite, followed by a series of lightning talks for a variety of topics on Android, including deep links on Android 12, building DoorDash's support app in Android, server-driven UI, and creating consistent and themeable Android UI components for DoorDash. With the last 15 minutes, we'll have a Q&A. Please feel free to go into the Zoom chat. At the bottom bar, you can go into the Q&A tab and drop questions in there during the chat. We may answer some questions live if they pertain to the talks, but we'll try to do the best we can to answer as many as possible at the end of the session. This event is hosted by the New York City Engineering Office. I am the New York City Engineering Site Lead. Just a bit about the office. It was launched in 2019, it's 3 years old. It's located in the Flatiron District in Manhattan, and we're over 140 engineers and growing. So really exciting. It's one of DoorDash's largest engineering offices, and we're hiring. So if you are interested in the talks today and you want to learn more about working at DoorDash, we are hiring Android roles in New York City and also in a variety of offices across North America, including San Francisco, Los Angeles, Seattle, and Toronto. We also have some remote positions if you're interested in that. So you can learn more by checking out our open Android positions on the career page at careers.doordash.com. Or if you're fast enough and you can open your camera, you can scan this QR code, but it just takes you to careers.doordash.com. So with that, I want to give a quick overview of Android at DoorDash. So DoorDash is a multi-app Android ecosystem. We have three main Android apps that power DoorDash. There's the consumer app, we have an app for Dashers, and the business manager. I'm going to talk more about each of those apps more in depth in the coming slides. Additionally, DoorDash is a Kotlin first Android environment. Over 90% of our code is Kotlin, and we encourage folks to rewrite some of the legacy Java into Kotlin. All new code and classes are written in Kotlin. At DoorDash, we have in the previous slide, we leverage a consistent MVVM architecture at DoorDash, which we call clean MVVM. You'll hear more about that in the app rewrite talk by Nick. And we have over 80 Android engineers at DoorDash working on those apps. So just a bit more on these apps. So first is the consumer app. If you've ever used DoorDash to order lunch or dinner, you might be familiar with the consumer app. For consumers, this is how they connect on DoorDash to bring their neighborhood to their fingertips. And while you might be familiar with our restaurant delivery, we're also expanding into other categories like grocery, home goods, and other retail categories. So it's a bit about the consumer app. What you might be less familiar with is the Dasher app. So this is what Dashers or DoorDash delivery drivers use in order to guide them through the delivery process. For Dashers, the Dasher app is a great way to earn extra money, whether you're a part-time student or you just need some extra cash. All you need is your car or a bicycle on the DoorDash app, the Dasher app, and you can easily earn some extra money. Last but not least is Business Manager, which is an Android tablet application that restaurants use to manage their DoorDash orders, update Dashers and customers on the order ready times, and increase their order volume and help make their businesses more successful. So before I hand it over to talk about the Android talks, I just want to leave you all with the DoorDash vision. Our vision is to connect every local business to every local consumer and bring them things in minutes, not days. It's a really ambitious vision, and we're still in the very early days of executing on this vision. And the Android platform and ecosystem plays a huge part in helping us realize this vision. So with that, I want to hand it over to Nick, who's going to talk about what we learned from our Android rewrite.
Thank you, Brian. Hi, folks. My name is Nick. I work on the Android platform team here at DoorDash for about 2 years now. I've been with DoorDash, and I enjoy rock climbing and skiing as well. And so today we're going to talk about our Android rewrite. For context, we started over with our app and rewrote it in 6 months. I'd first like to talk about some of the challenges we had with our old Android application. First off, we had acquired the Caviar Corporation from Square, and the Caviar app came with a hard deadline of June 6th, 2020 to deprecate and turn down their AWS resources. So we had a hard time commitment to bring Caviar and DoorDash together. At the same time, our app had multiple architectures going on at the same time. In fact, pretty much every single business vertical had their own sort of architecture inside of the app. If you've ever worked in an app with more than one architecture, this can prove quite difficult to work with. As each engineer, you'd have to pick up the style for the code that you were working in. And finally, the app had quite a few technical problems. It was slow, and we had reused fragment transactions and activity navigation willy-nilly across the app, so it wasn't clear what components were coupled with what. So we started over. We rewrote the app. We made some big technical changes, adopted a standardized clean MVVM architecture, and we migrated Caviar into the code base. This brought some big technical improvements. Page load speeds were decreased, load speeds, pages got faster, and we leveraged the navigation framework, which meant that there's a consistent way for fragments and activities to interact with each other across the app. We also implemented caching aggressively so that the page load times would be better if the content can be served from the cache. We had to make some tough choices in this process. How do we integrate Caviar? Like, you're taking two code bases and merging them together into one. What approach should we use for that? What architecture should we go with? There's a lot of different architectures out there today for Android apps to use. MVC, MVVM, bespoke architectures from other tech companies. And finally, should we start over and rewrite it from scratch? Or should we fix feature by feature and rewrite in place? Cool. So the first thing we did was we wanted to design an app that integrated Caviar into the DoorDash ecosystem. And we did this we implemented this using flavors and build config flags. Flavors only specifically for the resources, and build config flags for runtime checks such as is Caviar, go down this code path for this feature. This is interesting because we didn't lean too hard into flavors themselves, instead opting to mostly keep the code bases separate. Like, we only have one Kotlin source set and multiple resource source sets as well. This allowed us to switch at runtime to test both DoorDash and Caviar. And then we standardized this using the Prism components that we'll talk about later, so that they have every button and style has both a Caviar and a DoorDash look and feel, so that we can maintain a visual identity for both brands while having the same code base. We made some core architecture decisions. Now, there's many different Android architectures out there, and the one that we ended up with is pretty boring. And I think a boring architecture is good, especially for a company with 80+ Android developers. It's core to the Android stack. And so as Google pushes this sort of pattern more and more, we want to stay along those lines. It's just your standard MVVM, the repository and a cache, or hitting the network via retrofit, just not very difficult. We use both activities and fragments. The concept was essentially one activity per high-level feature and multiple fragments underneath it. This brings some benefits for deep linking, as Michael will talk about, and it sort of allows for separation of concerns as well. And then we'd like to keep our activities and fragments as simple as possible with minimal logic inside them, pushing that into the view model that's reusable between them instead. Now, all of the other architecture patterns out there are great, and it's an interesting thing to have a bespoke architecture for your app. I've seen other major tech companies perform a rewrite and spend a lot of time developing an architecture that suits them perfectly. This is great. I love working in a bespoke architecture like that, but it brings in a large cost of having to learn this architecture before you can work and be an effective contributor to this code base. So the next question was, should we rewrite from scratch or should we fix in place going forward? Starting from scratch is quite dangerous. Netscape made this mistake with Netscape 6, which you've never used or heard of because they got their lunch eaten by Firefox and Internet Explorer at the time. When you rewrite something from scratch, you lose all of the knowledge of why that code was written and working. Generally, as engineers, it's way easier to write code than it is to read code, and especially complicated code. You read it and it's like, I'm not really sure why it does that, but I'm going to rewrite it. And then, lo and behold, it'll break something down the line. So rewriting something from scratch can be dangerous, but it brings the benefit of being able to standardize on patterns and libraries and languages specifically, something that I'll talk about in a little bit. Also, rewriting in place creates a long tail of features that, which features do you rewrite first? How do you decide how to roll out that rewritten feature? And when you get to those core features like your application, it's kind of hard to say, okay, this release is the one with the new application. Sounds good. And you won't have consistency in the code base because you're never going to be able, and it's very hard to get to that final state. Software engineers, the last 10%, the hardest 10%. Cool. So through all these tough decisions and the 6-month process of rewriting the app, we learned some really key lessons. Consistency is great. How to roll out an app like this. There's a couple strategies that I'll talk about. Making the right choices and abstractions, and especially one that I wanted to highlight, payment specifically. And then finally, the benefits of aggressively locally caching data. Consistency. Being consistent with your library choices, your styling choices, and your language choices can bring a lot of benefits. Again, kind of the theme is a developer at DoorDash can just work across multiple verticals, multiple apps, without having to relearn what's going on in the code base. Obviously, we rewrote in Kotlin first. This is the breakdown of the languages before we rewrote, and then after 99.8% Kotlin. The other 0.2% are either Gradle scripts or terrible bash scripts that I wrote. I'm sorry for the folks that have to maintain those. And consistency, language consistency, tooling consistency. Avoiding the temptation to chase the next thing in the process of a rewrite is something that's quite prevalent and hard to do. As developers, we want to go and look and see what is the newest bleeding edge thing. And while, Alpha 6 of this various library might be a promising prospect, for a larger company, we chose a set of core, maintainable, tested libraries that folks have a lot of experience with. So Dagger, your standard Android stack. But this approach helps us work at scale because a developer is like, oh, I'm familiar with how to do this. I'm new to this company. Let's go ahead and use it. That being said, it's important for us to evaluate new technologies, what's out there today. How should we adopt it? How are we going to migrate to this thing in our code base? Let's do it all at once, or let's do it line by or feature by feature without avoiding that drift. That's the biggest thing in a large code base. Rollouts. Rolling out an entire app rewrite is something that's quite difficult. There's a couple ways to do it. First, there's the dual binary approach. Basically, what you do there is you compile your new app as a library to your old app, and then at the app launch time, you do a quick switch to decide which app to use. This is great and something that's really powerful, but you have to decide, when to roll out and how to do it. DoorDash is a very ops heavy company. And so what we ended up doing instead was saying, okay, we have a beta cut. This is the beta version. We're going to send it out to our ops folks and our opted in beta users to test and see, of course, after we've decided that everything works as it should, as we think, send it out to our ops, send it out to our beta users, get feedback, get metrics on it, make sure that it's good. But to do this, everyone's working up to this deadline. So you have this big ramp up effect, pros and cons and trade-offs. A hard code freeze can be a stressful deadline. And then caching. So one of the architecture choices that we made with the new app was to cache basically everything. There's a couple ways that you can cache things in an Android app. Specifically, well, I mean, there's many ways, obviously, but a couple ones that I want to talk about. And a L3 cache in retrofit is something that's really useful if your backend sends proper cache control headers. Adding a cache to your retrofit object will allow any response with a cache control header to be cached for future reads. This is great. It works pretty much out of the box. And then our backend, which is also going under a rewrite, or rewrite in place for our major backend component, didn't always send the cache control header. And so for what we did there is we took objects that came back from the backend that we knew we could persist, that didn't change that much, decided cache control strategies of our own on the client, and wrote them into a room database. It's about 10 times faster to read from your local cache than it is to make a network call. At least in our case, this is hitting that aforementioned backend service. Payments abstractions. This is a particular point of mine. Choosing the right abstractions when making an app is a constant battle. Deciding to either abstract something, there's a software engineering principle. You ain't gonna need it, YAGNI. Don't do an abstraction before you need it, but in fact, sometimes it can be quite beneficial. Payments is a specific Android one that I want to call out. If your app receives payments in some form, you're probably going to eventually want to use multiple payment processors, such as Stripe, Google Pay, PayPal, etc. Abstracting this away at the beginning is something that can be really beneficial later, and probably will be. Having a single payment method object that you pass around, rather than implementing like Google Pay specific hooks everywhere in your app, will save you a lot of pain. This isn't the only learning that we had from payment. My colleague Harsh has written a very great blog post with 8 more learnings, I believe, about implementing payments in the rewrite. And then finally, I'd like to give a big shout out and thanks to the team that got this done. It was quite a project to get all of the code written in 6 months, and without them, this wouldn't have happened. Next, I'm going to toss it over to Michael, who's going to talk about Android deep links.
Thank you so much, Nick. Hi, everyone. My name is Michael Yotive. I'm an Android developer on the consumer Android platform team. Today I'd like to talk to you about how deep links work on Android. So I know my title is rather sensational. Your deep links might be broken, but I do promise that this talk has good intentions. My intention behind it was to kind of take a step back, go back to the fundamentals of Android to kind of give you a refresher on how deep linking has worked in the past, and then also talk about a change that happened in Android 12 that affected us later part of last year. So let's talk about what happened. We've got a feature in the consumer app that allows customers to create a group order. And this is a really nice feature. Say you wanted to buy lunch for your coworkers, or if you wanted to order for your family and have all the items arrive together. So with this feature, you can select a store, start a group order, set a spending limit. But then once you've created this group order, you are given a link that you can then send out to your friends and coworkers to then add items to that order. From an Android user perspective, there's some interesting things that happen with this URL. From their perspective, if they've received it in, say, a text message or an email, when they click on it on their device, some would expect that this would take them to the mobile version of the site, right? The actual web browser, right? But from our perspective, from DoorDash, we want that to be a very seamless experience, especially if the customer has the DoorDash app installed on their device. So with deep linking, we can utilize that route, that HTTP route, and intercept, quote unquote, what's called an implicit intent. Okay, so when the customer clicks on this link, under the covers, Google is creating this implicit intent, which is asking the operating system for a list of activities that could potentially handle this request. So inside of this intent, we've got an action associated with it, in this case, action view. We've got a URI, which is just taking that URL of our group order, parsing it to a URI so Android could look at the individual bits like the scheme, the domain, any query string parameters, so on and so forth, and then also a category. And then when the Android operating system tries to, when you try to launch this intent, so next slide, please. So Android is going to go ask the activity manager, hey, what screens, what activities do you have that will match this intent? So it'll scan through all of the activities and ask that question. And the way Android knows which activities have can be associated with this intent is through that Android manifest. A lot of Android developers are very familiar with the Android manifest. This is where we have to list all of our activities that we could ever interact with inside of our application. So in here, I have an activity called deep link activity, and we can utilize what's called an intent filter to allow Android to utilize this activity when a specific implicit intent gets executed. So here we've got an action of view, we've got a category of browsable, and then we also have the data associated with it. Okay. But there comes a problem when Android finds multiple activities that can handle this request. This is Android's ability to be flexible. So when Android matches one or several activities, the customer or the user, the Android user, gets presented with what's called the disambiguation dialog. Okay, and this creates a little bit of friction for us here at DoorDash. We want that seamless native experience to take the user directly to our application, but here the user is presented with choice, and when presented with choice, sometimes the customer might not make the choice that we want. So the way we can get around this disambiguation dialog or the chooser dialog is by utilizing what's called Android app links. This has been available to us since Marshmallow, and Google has been slowly trying to nudge us into this direction of using it. However, as of Android 12, there was a behavior change that is now forcing us to use the Android app links. So on Google's documentation for Android 12 in the behavior changes section, there's a section for the web intent resolution. And it says that a generic web intent resolves to an activity in your app only if the app is approved for a specific domain in that web intent. If your application is not approved for that domain, then that web intent will resolve to the default handler, which 9 times out of 10 is going to be a web browser of some sort, probably Chrome. So how do you get around this? So you need to verify that domain using Android app links. So now Google is nudging you even further into that direction of using app links. So how do app links work? They're kind of a two-part thing that you need to do as a developer. The first part is inside of your manifest for the activity that has that intent that wants to handle that web intent, you have to specify Android auto verify equals true. And what this will do will inform Android operating system to look at the domain for this intent and go out to that domain's host and look for a specific file, okay? This file is going to contain all the information that Android needs in order to verify that you are the digital owner of this app and the domain. So next slide, please. Okay, so when Android makes this request, it's going to go out to your server and look for this absolute path. This asset links.json file has to live on your domain in a specific folder called the .well-known directory, okay? And inside this asset links.json file, next slide, please. You'll see it's just normal JSON. For most, you'll probably just have one node here for just your application. Here, I'm illustrating that you can have multiple applications associated with it. In this case, our debug application and our production application. And I know this is a lot of information. This is Google's digital asset links format, but really from the Android perspective, there's only 2 bits of information that we care about. It's the package name, which you can obtain from your build.gradle, specifically the application ID, and then the Shah 256 fingerprint, which there are various ways to obtain this. This is your public ID, right? So this is the ID that gets associated with your APK when you upload it to the store. It's what gets generated when you sign your application. So it assures that you are who is creating this APK, okay? And with this information, Google has all the information it needs to verify that your app and your domain are verified together. So what will happen next is when you click on this link, as long as you have your activity to handle this route, you'll be taken directly to your deep link, in this case, the group order. So the customer can then go ahead and start filling out their group order, okay? So if you need to verify that your domain is verified on your device, what you can do is go to the application settings, scroll down to open by default, and there, if you have everything set up correctly, it should say that your domain is now verified. Okay. So closing thoughts. In this talk, we did a big refresher on implicit intents, how they work on Android, how Android app links work, how to solve the disambiguation dialog. But if there's one thing that I want you to take away from this talk is test your deep links. This is a behavior change. So you're not going to get an API warning. You're not going to get a lint warning. When this happened to us, I think it was October, November, we started receiving reports that our deep links were only launching in the Chrome web browser. And this was the result. So if you use this HTTP style of doing deep links, test on an Android 12 device. If you haven't moved to the Android app links structure yet, do that now. Otherwise, your deep links will not be working as intended on Android 12. So I have a lot more that I could say about this topic. Please visit the DoorDash Engineering. I've got a big blog post on this on how you could test, and as well as some other information, but I'll leave you with that for now. And I'd like to pass the baton off to Ishita and Alekhya.
Thank you, Michael. So, hello everyone. I'm Ishita. I have been at DoorDash for 1 year, where I work on the chat experience team building their chat platform on Android. I have been an Android developer for 10 years, and in my free time, I love to spend time with my family and friends. So today, I and Alekhya will talk about building unified chat experience on Android. So these are the top user experience and technical issues we found with our legacy support chat. So as you can see in the GIF, the most common issue we found is where user has to fill up a form first. And once they are connected to the agent will ask the same information again, which will be a little frustrating for users. And also if the chat get dropped for some reason, then when the customer is connected to the new agent, customer had to explain that issue again. So there was no way to share the issue context ahead of time with agent. Also, there was no automation, so it was hard to provide faster resolution and customer had to wait for agent. Also, the technical issue we found is our legacy chat was fragmented across different type of users, like consumer, dasher, merchant on Android. So this became very hard to maintain and created a lot of duplication of effort. So we created a unified chat solution in 2 iterations. So I'm going to talk about the first iteration, in which I'm going to how we solve about the first technical issue, and Alekhya will cover the second iteration, in which she will talk about like how we solve the automation and customer experience issue. So in first iteration, building unified chat library, we achieved this goal. First one is reduce redundant code by putting all the logic related to chat in single chat library. So we do not need to write code for each user application. Second one is build a scalable platform by integrating chat library to different user application like Dasher app, we have consumer app, merchant application. Third one is to provide unified chat experience using common chat UI to all our user application across DoorDash. So this is our chat library architecture, and our chat library is written in Kotlin. So as you can see, there is a support chat and in-app chat. So they are sharing UI component by which we can provide unified user experience. Library will talk to backends, so all logic resides at one place. So it's easy to maintain and we don't need to write redundant code. Also, you can see that library will talk with client user application via API interface. So it makes it scalable and easy to integrate with different user application. So what kind of consideration you can take while creating the library? So first one is add customization. So when you are building a library can be used for different clients. So make sure that like UI is customizable based on the user application. Second one is provide Kotlin and Java interaction. So in our case, our library was written in Kotlin. So if the user application is written in Java code base, then make sure that like you use JVM annotation to avoid compile time errors. The third one is use modifiers while exposing code. So definitely when you are writing library, you don't want to expose like all the code to the user application. So in Kotlin, try to use like internal visibility modifier, and in Java, if you're writing in Java, you can use, there is a default one, package private. The fourth one is create a test app. So when you are writing a library, it's very hard to test. So make sure you have a test app. So if you are making any UI changes, it's easy to test. The last one is avoid exposing resources. So by default in Android, all the resources are public. So if you just keep one resource, if you just list one resource as public, that will make other resource private. So that's all from my side. Thank you, everyone. Now I'll hand over to Alekhya. She will go over the second iteration.
Thank you, Ishita. Hi, everyone. I'm Alekhya, working as an Android developer, helping build chat at DoorDash. Been here at DoorDash for close to a year. So I will talk about the improvements we made as part of our second iteration. The GIF on the right displays the our new chat versus the old chat that Ishita took us over. So basically, our focus was on improving customer experience, where user can directly interact with a live agent, also increase the reliability. This is by making sure the chat connection is consistent and stable, and also provide automation for quicker issue resolution. Next, please. Let's talk about how we automated our chat by implementing two new features. One is through chatbot, where user can select an option directly from a list of options relevant to their issue and get quick response. Second is through quick links, where user will be directed directly to a self-help screen or a screen that helps them resolve or address their issue quicker. Next slide. Okay, let's talk about chatbot. So we know how users want to get support as soon as possible with minimum wait times, waiting for agent to connect, or spend time explaining their issues. So that's where chatbot helps. It provides quicker resolution in such cases. So on Android, the way we implemented this is consider this chat recycler view, where every message is a different message type. We pass the payload received at the front end from provided to us basically, and identify the message type and display them in the correct view. So in case of chatbot messages, we look for the message type chatbot and then pass the list of quick responses to be displayed in a custom view in the chatbot flow. And we also set up on-click actions to be able to trigger the next action in the chatbot flow. So the benefits of this is it helps us reduce the customer wait times to get support and they can get support for their issues quicker. And it also helps us engage users sooner and involve a live agent only when required. Next slide, please. So the next feature is quick links. So it's similar to quick reply, whereas implementation wise, but I think the concept is basically the app looks for when the user is on the chat and we parse for the quick link payload, we take the user directly to the required screen, the self-help screen, to resolve their issue. And the benefits of this is basically it helps direct user to the appropriate screen, and it doesn't require any familiarity with the support section of the DoorDash app. So this helps provide user better feedback and faster feedback. So to summarize, both these features were implemented in the chat library that Ishita mentioned and is reused across the consumer or Dasher or the other apps at DoorDash. So the benefits of all these efforts of revamping or chat related changes is basically scalable, to make it scalable, that is continue providing support to large number of increasing users, make it reusable, that is to extend it to multiple platforms. So currently we support this chat in the consumer and the Dasher apps. In future, we would like to extend it to merchant app or any new apps that DoorDash decides to support. Also internationalization. So chat can be extended to multiple markets where the across different languages. So that is it from me. Thank you to all the team who helped make these changes and made it a success. And I will hand it to Kevin, who will talk about building server-driven UI.
All right, thank you. Well, hello everyone. Welcome to this section of the presentation. My name is Kevin. I'm an Android engineer in the consumer platform team here at DoorDash. So today I want to talk about one of the projects I've been working on. I want to share how we build a server-driven UI pattern in DoorDash. Next slide. First of all, there are 3 high-level goals a server-driven UI pattern can help to achieve. It can help to achieve flexibility in operations by allowing teams to experiment features using the components already in the app without making client-side changes, so that feature can iterate without app release cycle. It can also help to consolidate business logic in the backend and allowing client-side engineers to focus more on the UI display. And lastly, by building reusable components in collaboration with the design team, it can help to achieve consistency in UX across apps and the clients. So as you see in this slide, in the DoorDash consumer app, Lego is the server-driven UI framework in the client side that helps to achieve those goals. Users are able to get a different experience depending on the backend response. Next slide. Here are some of the current pages in DoorDash consumer app that are built on top of server-driven UI pattern. Our homepage, along with some other screens in the app, are backend driven. In the next slide, as you can see, by simply changing the backend response to update the component ID, the client side can easily provide a different UI to users, which allowing engineering team to be more flexible for product requirements. Now, you may wonder how complex it is to achieve a server-driven UI pattern in this fairly complex UI layouts showing here. So in the next slide, first of all, I'm going to explain the concept how the generic UI components work. Then we will take a look how it works on the Android side. So starting from the Lego API response, the building block of the Lego contains all the information client needs to know to render views to the user. A facet represents a UI view that contains fields such as tags, images, events listed here. And on the right side of the screen, we have a store card containing text attributes. And each facet may contain an array of facets as children. This is in fact how complex UI patterns can be mapped. Next slide. As shown in this page, we have a list of nested components in the response. On the left side, in the diagram, component C contains an array of other components as children. By using this pattern, both parent component and child component can be backend configurable, which serves as the building block for server-driven UI principle. Now, we understand how the Lego response is structured. So I'm going to talk about how it was built on the Android side. As Nick previously mentioned, in the DoorDash consumer app, we're using MVVM architecture to build the application. And we chose epoxy library for building complex screens in the recycler view. As shown in the diagram here on the left, when rendering a server-driven UI page, it first fetches the data from the backend. and repository will make the network call to retrieve the Lego response. Once the data is ready, it will be mapped to the domain model. In this step, all the attributes in the network model will be translated to something app will understand. Each facet may contain events, which including navigation and pagination and other custom actions. The backend will return those actions in a raw string format in the response. Once mapped to domain model, it will contain necessary information the app needs to know. Then the view model will return the domain model list of facets back to the fragment using live data. Each facet contains the component ID that will be mapped to a specific UI views. For nested components such as carousel, since it has direct access to children components, it is easy to bind children to the UI view as well. Then in the fragment, we pass the data and action callback to the epoxy controller, which in turn binds the data to each fragment and wire action callbacks to listen for user actions. On the right, as you see, upon user actions, events will be triggered back to the view model to perform necessary actions such as pagination or navigation. Next slide. So now I want to share some of the learning so far. So first of all, heavy user interactions and state management is something to consider when deciding to make a page server-driven. In the homepage of the DoorDash consumer app, users are able to select and filter the type of food they would like to see. If we make the state management server-driven, that means additional API calls are needed when user changes the state, which will impact the latency and also user experience. So in our case, we still keep the state management at the client side. Also in the experience of team first onboarding to Lego framework, there's upfront costs to be considered that will add time to the project. For example, new components will needed to be added, and versioning and validation on the backend side is something else to be considered as well, because there are usually multiple app versions available to user during the release process. Making sure legacy app version do not get impacted by introducing new component is very important. With that, thank you for listening. I'll hand it over to Will to talk about creating consistent UI components for DoorDash.
Thank you, Kevin. Hi, everyone. I'm Will. I'm a design technologist on the design infrastructure team working on our design system for Android. I've been here for 6 months. Today, I'm going to share with you how we create consistent and themeable UI components for our Android apps. So as you have seen earlier in the presentation, at DoorDash, we have multiple Android apps, and each of them is designed with its own branding and uniqueness. And as you all might have experienced as Android engineers, implementing UI designs for one app or multiple apps within a company comes with a lot of challenges. For example, to get the visuals right, it takes a lot of attention to details and time to do pixel pushing in order to get the text, icons, components aligned and matching the designs. And if you're working on one app, it's likely to see the same component being used repeatedly in different screens. So you need to build with reusability in mind and avoid, in order to avoid duplicating code in different layouts. Right? So if you're working on multiple apps within the company and each product has its own branding, you need to support theming for the UI components that you have built. And lastly, if you are looking to provide inclusive access for your apps, you have to ensure your UI is compliant to different accessibility standards like high contrast colors, big enough tab targets, and even supporting screen readers like TalkBack. Next slide. So these are all the problems we have faced as Android engineers. And to help make our lives easier at DoorDash, we have created our own design system called Prism. It's a combination of foundations, components, tools, principles, and documentation that helps our designers and engineers work more efficiently and cohesively together. And specifically on Android, the design system library provides foundations as XML resources like themes, styles, colors, icon vector drawables, size dimensions, etc. And the Prism components are available as Android custom views. So this way, Android engineers on the client teams can focus mainly on implementing screens and less on building these components and foundations. So let's take a closer look at our themes. So the design system library comes with 3 themes, and they are all following the same structure as the themes offered by the Android framework or the material design library. And on top of that, we have developed our own set of semantic attributes that we use to reference resource values specific to the theme. Next slide. So by assigning values to the attribute in the theme, it allows our components implementation to be theme agnostic. So for example, we can have a single shared implementation for our components across themes by using color selectors and state drawables, and then reference the theme attributes inside them. So, and then at the layout inflation time, like these attributes are resolved via the theme to get the proper color integer value to tint the component. So another advantage for this setup is that any subsequent color changes will just happen at the theme level without having us to modify the component implementation. Next slide. So these semantic attributes that we use are not only applied to colors, but also to like text appearances, shapes and sizes, etc. So when we have multiple components and multiple themes combined in the system, then that list of attributes could easily go up to 1,000. So, and at the same time, we have to ensure that all the other platforms like iOS and web have the same semantics available to them. Then it becomes a challenge for us to keep everything in sync. Next slide. So to help us keep everything in sync, we rely heavily on code generation for each platform through an open source library called Style Dictionary. So this allows us to define component properties in JSON definitions, and then use those definitions to generate code in JavaScript, XML, and Swift. Next slide. So taking a closer look of the JSON files, they act as a single source of truth for our foundations and component specs. And all the generated values have consistent namings across design and engineering platforms, with just slight differences that adheres to the naming conventions for each platform. So this allows us to communicate more efficiently, as we can use the same terminologies from design to engineering across all the platforms. And next slide. To summarize, so by doing code generation from Figma to platform code, it helps us keep our component visuals in sync and standardize communication between design and engineering. And then by offering a wide range of reusable components that supports theming and different styles, we can avoid duplicating UI code across projects. And then by implementing accessibility support into the components and using a color palette that meets color contrast standards, then all these features built by engineers using these components will get accessibility support for free. And these are some of the ways. So these are some of the ways that we use to use the design system to help us tackle these UI challenges. Thank you.
Awesome. Well, and for the rest of the presentation, the presenters, thanks so much. That was awesome. We got a ton of questions from the audience. Thank you all for being so engaged. We're not going to be able to answer them all. We have answered 60 in Zoom, and we'll do a couple live as well. So the first one, I saw a lot of people ask, why didn't we use Compose during the rewrite? Nick, I'm sure there's a really good reason for that. Maybe you could speak to that and talk about, like, do we have plans for Compose in the future?
Yeah, absolutely. So I can answer questions around Anvil, Hilts, Compose, and coroutines, as well as Flow. All of these technologies that are really cool and bleeding edge, well, cutting edge now, I guess. But when we did the rewrite, it was actually started in late 2019 and completed through mid 2020. So at the time, a lot of these libraries were some of those alpha or beta libraries, or not quite as well adopted in the community. I believe if we were to start this process again today, we would absolutely leverage many of these technologies. Specifically, Hilt, something we're migrating to internally at some point soon, as well as another one, but not Compose as far as I know. So hope that answers everyone's questions around those technologies. Yeah. Awesome.
Thanks, Nick. Appreciate it. Okay, Michael, for yours, there were quite a few questions around leveraging the navigation API to handle deep links instead of having multiple activities, and how we handle our navigation stack after deep linking. maybe you could speak to that a little bit because there were quite a few questions around it.
Yeah. We use navigation components in the consumer app. We don't use it for deep linking right now, but I think that's a great idea of being able to at least visualize all the different routes and all the different entry points and how we can get to the applications. It's definitely something that I would love to take a look at and love to consider. And on top of that, navigation components do support the Android app link. So on your navigation graph, you can just say auto verify true, and it goes through the same process we talked about with the implicit intent. So it's definitely something I'd like to do. Definitely a big effort on our part, though.
Alekhya and Ishita, there were quite a few questions like about the chatbot, and I think people were curious, like, are we using a third-party library integration? How are we doing NLP, natural language processing? I don't know how much we can share there, but there's like 3 or 4 questions around it, so thought I'd pass it over to you.
Yes, for chat entirely, we are using a third-party SDK, which is Sendbird, that enables us to embed the chat within our apps. For chatbot, we are using a combination of internal tools and a third-party application like NLP platform, basically. So the internal tool is basically used to design and render the flows, and those same flows are mapped to the third-party NLP platform, which triggers these flows for us upon click and responses.
Awesome, thanks, Alekhya. Okay, there's quite a few good ones for server-driven UI. So I think a good one was just around like navigation. There were a couple questions there. So do you have a known set of actions that can happen in server-driven UI when a user clicks? How do you handle navigation? Are deep links used or something else?
Yeah, so for the navigation, I think we actually passed the URL into the response. So we internally were using deep link to navigate to different pages.
Awesome, very cool. Okay, Will, this one's for you. Do the design themes have different dimension values and text sizes for different density buckets, or are they constant dimension values and text sizes across all screen density types?
Yeah, so we have a fixed set of dimension values and text sizes, but then we would be assigning different values across themes. So for example, on the consumer theme, on the consumer or the caviar theme, we will have smaller text sizes for the toolbar title, and then on the merchant, because it's because it's a mobile app, and then on the merchant theme, we'll assign it with a larger text size value because the merchant app is a tablet app.
Awesome, thanks, Will. Okay, I'm just going to keep round robin the folks. So Nick, you're up next. There were a couple questions about modularization of the Android apps. I know we've talked about this, and curious if you could share.
Yeah, absolutely. Modularization is my current project of this company. We're planning to split the consumer app up from the few modules it has right now into many, many more. Unfortunately, it wasn't something that we pursued out of the gates, and probably something that I could have mentioned in the talk. Modularizing your app as you rewrite it is something that will pay dividends later.
Awesome.
Yeah.
Thanks, Nick. Excited for that to get rolled out. Okay, Michael, I think this one came up during your presentation on deep links. There were quite a few questions about reactive Java coroutines in production at the same time, and folks wanted to know, like, why are we doing that? Or does that mean we have separate execution thread pools and that causes some overhead? So I don't know if you have a POV on that, if you could share, but I think like a few people were asking about that.
Yeah, I have kind of an opinion about it, but maybe Nick wants to chime in here as well. But yeah, we are exploring coroutines at this time, and mostly just because it's something our developers have been very interested in. We did a big brainstorming session back in January. It just kept coming up that we want to do coroutines. So that's what we're trying to figure out now. Nick, do you have any other perspectives?
Yeah, absolutely. In a large app, it's important to figure out your migration strategy more than a specific technology choice. Personally, like RxJava and coroutines offer a lot of the same functionality, and I think most Android developers are familiar with one or the other or both. So having a consistent code base that uses one or the other, especially when it's 100,000 lines plus, probably more than that now, a million, is more important. So if we switch over, we want to do it all at once, I think. Still TBD.
Awesome. Thanks, Nick and Michael. Okay, there's another question on unified chat for Ishita and Alekhya. Do we persist the chats at all, like between sessions and whatnot, or every time you go in, is it like kind of a fresh session?
Yeah, I can answer that. So yeah, for chat, actually, once the chat is started, support chat, we actually cache that channel URL. So that way, like, if they don't need to reconnect with the new agent, so they can start a new, like if they have any question, they can restart and they can ask any question.
Awesome. Thank you, Ishita. It's very cool. Okay, we have a couple minutes left. Maybe we'll just do like maybe one more question. Okay, for Kevin on server-driven UI, there was some interesting questions about like backward compatibility, specifically what happens if there is a Lego component that's served by the server, but it's not supported by an older version of the app. Like, how do we handle that?
Yeah, I think that's a very good question. Also, that's, I think, something I mentioned about during the talk. The versioning is something to be very important, because if you think about it, at any given moment, like it depends on how the Google release the app, there could be like many different versions of the app exist at the same time. As a matter of fact, I think we did some investigation like about like maybe a version of the app which we released maybe like 6 months ago. There are still like maybe even like about 1% of users still on that. So it's very important. So for adding a new I think components to the server-driven UI, that it's really important to send whether the backend will need to know the client-side app version, so that it doesn't send the wrong component and components to the app release, so that it just doesn't know how to handle it.
Awesome. So it sounds like the server is aware of the app version and the compatibility of the components, and you can filter there. I would assume maybe the clients can handle them.
Yeah, I think currently we are on the request side, we are actually sending the header to the as part of the request, so that the backend will know actually what the version of the app actually is coming from.
Awesome. Kevin, thank you. Hey, y'all, that's all the time that we have today. I'm sorry, I know there was a lot of enthusiasm and questions. I'm sorry we couldn't get to all of them, but I want to thank everyone in the audience for coming, and also thank all the presenters for taking the time to do this presentation. It was awesome. It's great to see kind of everyone really engaged with it. Just a reminder, if like you are interested in these kind of problems, DoorDash is hiring. You can find some of those roles on careers.doordash.com. My name is Brian Donahue. You can also like find me. My email address is out there on the internet, and I'm happy to answer any questions as well. So thanks again. Appreciate it.